Hello everyone. In part 1, we have seen how to integrate the camera sensor in Isaac Sim. Then in part 2, we have seen how to integrate the IMU sensor in Isaac Sim. As mentioned in the last parts, in part 3, we were going to cover both 2D and 3D LiDAR sensors, but the video would become lengthy. So in part 3 I am just showing the 2D LiDAR sensor, and in part 4 I will cover the 3D LiDAR sensor. So let's start with the 2D LiDAR sensor. In the stage panel, you can see this LiDAR prim that is XT_32_10 Hz. I know this is a 3D LiDAR sensor, but this is a simulation, so we can configure the sensor according to our use case. So please do not get confused. In this prim, the sensor is not yet added, so let's add the sensor in this prim. So go to Create, then Sensors, then PhysX Lidar, and select Rotating. This is the 2D LiDAR. We have previously used this sensor in Tutorial 5 to obtain the occupancy map. If you have not seen that tutorial, please watch it for a better understanding. Once the sensor is added, you can see that sensor in the stage panel under the selected prim. I have selected the LiDAR prim, so you can see the sensor is added here. Now select the sensor. In the Properties section, scroll down, and you can see the raw USD properties. Expand it. Here you can configure the sensor according to your sensor specifications. By enabling draw lines and draw points, you can see the laser beams in the simulation. Then here you can configure its horizontal field of view and resolution, then minimum and maximum range. Then the rotation rate of the sensor, and vertical field of view and resolution. These settings will affect the output even though we are using the 2D LiDAR, because we selected the PhysX Lidar sensor. So run the simulation, and let's see the laser beam. Here you can see the laser beam is rotating. So let's stop the simulation. The next step is to get this data on a ROS2 topic. As you know, for that we need to create an action graph for this sensor, which will take the data from the simulation and publish it on a topic. But here you can see that in default action graphs in Isaac Sim, action graph for 2D LiDAR scan is not provided. So let's create our own action graph. Go to the stage panel and add an action graph. Drag this action graph under the graph group and rename it as ROS_LiDAR 2D. And click on Edit Graph. Firstly, we need on playback tick. This block executes every simulation tick. Then we need ROS2 context. This block initializes ROS2 communication. Then, to get the sensor data from the simulation, we need the Isaac Read LiDAR Beams node. If you do not understand any procedure, or if you are getting any error that did not occur for me in this tutorial, you can put that issue on my Discord channel, where we can help each other by solving the problem and learn Isaac Sim and Isaac Lab in a better way. This sensor is also time dependent, so we need to add the Isaac Read simulation time block. Finally, to publish the data on a ROS2 topic, we need the ROS2 publish LaserScan block. Now make the following connections. Here we do not need to connect vertical field of view and vertical resolution. Now finally connect the simulation time. Select the Isaac Read LiDAR Beams node, and the final step is to add the target prim. Click on Add Target, then select the appropriate LiDAR sensor. Now click on the ROS2 Publish LaserScan block. Here you can change its frame_ID and topic name as per your requirements. I am keeping it the same. Now run the simulation and open the terminal, and check the ROS2 topic list. Here you can see the scan topic is publishing. Let's check its data. Here you can see it is publishing the data on the scan topic with frame_ID sim_lidar. To visualize this data in a better way, we can use ROS2. So let's open ROS2. Click on Add, then by topic. Under the scan topic, you can see LaserScan. You can confirm this topic name from Isaac Sim here. Now select it and click on OK. You can see LaserScan is added in the left panel. Now expand this LaserScan and set the size to 0.1. Now to see the output, we need to select the correct frame. So click on Fix Frame and type sim_lidar, which is our frame_ID. Note that sim_lidar is not directly showing in the drop-down menu, because we are not publishing the transform tree for the robot. We will see that in the next tutorial, so stay tuned and subscribe to my channel. You can confirm the frame_ID here in Isaac Sim. Now you can see the output in red, so it is correctly scanning the warehouse. To see the output, you need to select the correct frame. So this is how you can integrate the 2D LiDAR sensor. So this is how you can use the 2D LiDAR sensor. In the next part, we are going to see the integration of 3D LiDAR sensors in Isaac Sim. So stay tuned and subscribe to my channel. If you like this video, like the video, share it with your friends, and if you have any questions, put them in the comments, or you can reach out to me by Discord channel. Thanks for watching.